I welcome you all to this session on powder metallurgy. Today we are going to start a very important discussion on one of the most important aspects of mechanical engineering, that is manufacturing. Now, how much importance do we give to manufacturing? As soon as we get up early in the morning, we go to our washrooms, we use the brush to brush our teeth. How much attention we give that how that brush is manufactured? Like I am sitting on a chair, how the chair has been manufactured, how much attention do I give to it? The table, the mouse I am using, the computer we are using, how much attention we give to the manufacturing aspect of all these things? All these things are directly related to our lives, but how much attention do we give to the manufacturing aspects of all these things? So, these series of lectures that we have started today will cover powder metallurgy as well as the sheet metal forming operations. So, there will be series of 12 lectures, out of which 3 lectures will be dedicated to powder metallurgy and 9 lectures will be dedicated to sheet metal forming operations. So, today we will start our discussion on powder metallurgy. So, as we go through this lecture, I will just like to introduce or give to you the overview of how we are going to go about in this 3 series of lectures on powder metallurgy. First of all, there will be a brief introduction to manufacturing, as I have already given you a brief overview that how much important manufacturing is to our lives. As I have already given example of toothbrush, of chair, of mouse, of television, of water bottle, of glass, all these things have been manufactured using one or the other processes. We can leave apart some of the things which have been made by God. If we say mountains have been created by God, we have not made them, but there are some certain other things which we have made, like some of the examples that I have already quoted in the beginning of the lecture. So, we will see that what are the different types of manufacturing processes like casting, welding. Just a brief introduction will be given, then we will come on to our major topic on introduction to powder metallurgy. Then how powder metallurgy compares with the other manufacturing processes. Like any product, if we say a water bottle, it can be manufactured by a number of manufacturing processes. So, how powder metallurgy is important and how powder metallurgy competes with the other manufacturing processes, that will be seen in this topic on powder metallurgy, a competitive process. Then we will come on to the process details. This process details will encompass preparation of metal powders, mixing, compacting, sintering and secondary operations. Just to give you an overview, powder metallurgy is a process in which we make the powder of the metals. This powder is then mixed with some of the dilubricants or different types of additives. The complete mixture is then compacted. Compacted means it is pressed under die and punch, and then we heat treat it, we give it some temperature, and then finally there are certain secondary operations which are carried out to make the products made by powder metallurgy more applicable. Like there are certain application spectrum for which we make products by powder metallurgy. So, these secondary operations like machining, coining, and there are a number of other operations which we will see during the course of these 3 lectures, which are done on the powder metallurgy parts to make them more and more suitable for the applications. Then coming on to the another important aspects, that is economics and design considerations. Now, we selection of a manufacturing process is very important. Already I have told that there are number of manufacturing processes that can be used to make a simple product. A simple product can be made either by casting, or it can be made using machining process, it can be forged, it can be shaped, or it can be made using powder metallurgy. So, as an entrepreneur, as a manufacturer, I would like to make a product in the cheapest possible manner. Now, cheapest possible manner means that I make maximum profit out of that. So, economics and design consideration, we will see that how important are the economic considerations for powder metallurgy parts, how they can compete with other manufacturing processes. Moreover, we will see the design aspect. Now, each and every part, each and every design, it is not possible for us to make it using powder metallurgy. So, there are different types of design aspects which have to be taken care of, which will be shown using the help of some diagrams. Then we will come on to the last aspect, that is the application areas where the powder metallurgy parts are finding applications. Then we will discuss what are the advantages of powder metallurgy parts. Like powder metallurgy can be applied to diversified application. As we use ballpoint pens, the balls can be made by powder metallurgy. We have different bulbs, the filament of the bulb, that is tungsten filament, is made use of powder metallurgy. So there are varied application areas. So we will see in the course of lectures what are the application areas for powder metallurgy, what are the advantages of this process, where we can use powder metallurgy, and what are the limitation areas. So all these things will be covered in course of these 3 lectures. So these 3 lectures will be dedicated towards powder metallurgy. Now, as I have already told, we are going to start the discussion with a very basic definition of manufacturing. So manufacturing in its broadest sense is the process of converting a raw material into the final products. Now we can take example of a mouse. Now this mouse is made up of a plastic material. So plastics are of different kinds. So depending upon the kind of the plastic material, we can choose a manufacturing process, like we can make use of injection molding, we can make use of compression molding. So this mouse has been converted from a raw plastic into its final form. So similarly, manufacturing converts any product, any raw material into its final form. So manufacturing encompasses the design of the product, the selection of the raw material, and finally the sequence of processes through which the product will be manufactured. Now coming on to point wise point, first point says the design of the product. Now the design of the mouse, the example that we have chosen, the design we can see this, the design is such that it is an ergonomic design. Our hand fits on the mouse like this, I can press it very easily. The second part is the selection of the raw material, and the third part is the sequence of processes through which the product will be manufactured. Now the selection of raw material is also important. We have to decide that what type of material should be used for making the mouse. Similarly, the sequence of processes through which the product will be manufactured. There are different techniques through which this mouse can be made, but simply the most important process, that is injection molding, can be used. There can be other processes that can be used for making this mouse. So as we can see, there are 3 important aspects of manufacturing. The first one is the design of the product, the second one is the selection of the raw materials, and the third one is the sequence of processes through which the product will be manufactured. So we are here to discuss regarding the sequence of processes through which the product will be manufactured. The important point is the design of the product, the selection of the raw material, the sequence of processes. So the design as well as the selection of raw materials will not be covered during the course of these lectures. We are going to focus our attention only on the sequence of processes that convert a raw material into a final product. Now coming on to the basic manufacturing processes. The broadest category of processing methods for materials are as follows. The first one being casting. Now casting can be expandable mode and the permanent mode. Expandable mode means all of us, maybe some of us might have visited the foundries. What do we do in the foundries? Basically we make a mold out of sand, and that sand mold is used to pour the molten metal to get the final shape. So that is a kind of expandable casting, in which the mold, once after the casting has been prepared, is broken down. The second important category is the permanent mold casting. In permanent mold casting, the mold is permanent. The mold is made up of different types of tool steels or die steels, and we pour the molten metal into these die steels to get the final shape of the product. So casting is one of the most primitive types of manufacturing process. Coming on to the next category of manufacturing processes, these are forming and shaping. So what are the different processes that fall under this broad category? These are rolling, forging, extrusion, drying, sheet forming, powder metallurgy, and molding. So in casting we are making use of a molten metal. In forming and shaping, either we heat the metal before we use it, or we can use it in the cold form also. So we can see that we are here to discuss the basic concepts of powder metallurgy, and powder metallurgy falls under the broad category of forming and shaping operations. Now coming on to the third broad category of manufacturing processes, these are machining processes. What are the processes that fall under machining? These are turning, milling, boring, drilling, planing, shaping, broaching and grinding. There are some unconventional machining processes also, which are ultrasonic machining, chemical, electrical and electrochemical machining and high energy beam machining. So, what is the basic concept of machining? In machining, whenever we want to give the final shape to the product, we remove some of the material in the form of chips. These chips can be either continuous chips, discontinuous chips or chips with built up edges. So, here we are losing some of the material as the waste material, because some of the material is being removed from the raw material to get the final product. So, till now we have seen that there are three important manufacturing processes. Those are basic manufacturing processes which have other subsequent processes falling under their categories. These are casting, forming and shaping as well as the machining. Now, coming on to the next manufacturing processes, those are joining. Now, joining encompasses welding, brazing, soldering, diffusion bonding, adhesive bonding and mechanical joining. Now, joining can broadly be categorized into two subcategories. These are permanent joining processes and temporary joining processes. Now, mechanical joining, we make use of fasteners. All of us see nuts and bolts. Nuts and bolts are used to join two different parts together. Whenever we want to use them or dismantle them, we can remove the nuts and bolts and we can use them again. Similarly, welding, brazing, soldering, they make the permanent joints. Once the joint has been made, we have to break the joint to get the individual parts again. So, joining processes are also important manufacturing processes. Then coming on to the finishing operations. Already we have seen there are four basic manufacturing processes, namely casting, machining, forming and shaping and joining. Now, why finishing is required? Sometimes these are the days of packaging. Everybody likes to have the product which looks very good, which has very good packaging. The surface finish should be very good. So, to have a very good surface finish, we use some of the finishing operations. So, these finishing operations are honing, lapping, polishing, burnishing, deburring, surface treating, coating and plating. We see most of us use cars. In cars, we see the finish of the sheet metal, that is there, the main body of the car, it is glowing like anything. So, that is what these are coatings and platings given to the sheet metal to give them a very luster like finish or a metallic finish. So, finishing processes are also very important manufacturing processes which comes under the broad category of manufacturing processes. So, we can see that to convert a raw material from its basic form to a usable form in the form of a final product, we use different types of manufacturing process. So, the present series of lectures will highlight powder metallurgy as a manufacturing process, focusing on process details, design aspects, economics of the process, advantages and limitations. So, now we will start our lecture series on powder metallurgy. There will be around 3 lectures or 3 sessions on powder metallurgy. Now, this is the powder metallurgy process. Already we have started the discussion with the basic concept of powder metallurgy, which is that we make the powder of the metal. This metal powder is then mixed with different types of additives. These can be dye lubricants or some other kind of wax or polymer based lubricants. Then this process is called mixing or blending. So, we have a metal powder. That metal powder is then mixed with the lubricants, then we get these two things together. Then finally, we press this mixture into a die and a punch with the help of a die and a punch. Now, this can be carried out either in a hot condition or it can be carried out in a cold condition. Similarly, we call this process as the process of compaction. So, this compaction can either be hot compaction or it can be cold compaction. Now, in hot compaction, it is there are number of technologies or number of techniques which can be used for hot compaction processes, like isostatic compaction, extrusion, die compaction, spraying or pressureless sintering. Similarly, in cold compaction there are number of processes which can be die compacting, isostatic cold compaction, rolling, injection molding, slip casting. So basically in these first 3 steps we have seen that we make a powder of a metal which is then mixed with certain additives, and then with the help of these additives and as well as the powder, this mixture is pressed under the applied pressure, and there are different processes which are used to press this mixture. Now after that we sinter this product. What is sintering? In the layman's language we can say that sintering is basically a heating process, heating up to a certain level of temperature which is below the melting point of the metal powder. Now metal powder, if we are using suppose we take example of titanium or tantalum, it has certain melting point. So in sintering we will raise the temperature to a level which will be lesser than the melting point of that metal, like the metal powder will not melt in case of powder metallurgy. So now we can see, as we can see, after the sintering either we can come down to the finished product, or after the sintering there are certain other processes which can be used to give the product its final properties. Now we can see there are optional manufacturing steps. Either after sintering we use the product in its desired form, or we pass on the product to these other optional manufacturing processes. Now these optional manufacturing steps are repressing, coining, sizing, resintering, forging, retrofitting, metal infiltration, or sorry, this is not retrofitting, this is re-rolling. So again I will go through the other optional manufacturing steps. These are repressing, coining, sizing, resintering, forging, re-rolling, or metal infiltration. Or there are other optional finishing operations. Already while discussing on the basic manufacturing processes, I have told you that why finishing processes are required to have a very good surface finish. Now that surface finish will come if we subject our product to these finishing operations. So what are the finishing operations that can be done to powder metallurgy parts? So these finishing operations basically are machining, heat treating, steam treating, plastic impregnation, plating, tumbling, oil impregnation, and shot pinning. So now again basically going through the summary of the powder metallurgy process. This process basically makes the powder of the metal, then this powder basically is mixed with the dye lubricants, or it is mixed with different types of additives. The mixture is then pressed under the compaction processes. The compaction processes can either be cold compaction or it can be hot compaction. Then it is sintered. Sintered means it is heated at a elevated temperature. After that it can be used as a finished product, or it is subjected to some optional manufacturing steps. Now these optional manufacturing steps are employed so that whatever mechanical properties or the physical properties or the chemical properties of the final product or the specifications of the final product are required, those final product, those specifications, those mechanical properties will only come if we subject this sintered product to these optional manufacturing processes. Like we can take a simple example of self lubricating type of bearings. So self lubricating type of bearings are manufactured by powder metallurgy parts. It's a powder metallurgy part and it is manufactured using the process of powder metallurgy. So what is so special about this self lubricating bearings? Usually we use bearings are there in cycles and in other rotational members. We apply grease with hand in in normal lubrication bearings. But here in self lubricating type of bearings there are certain pores in the powder metallurgy part which we will see in the subsequent lectures. These pores are filled with some kind of a oil. So oil infiltration is done. So it is one of the optional finishing steps or optional manufacturing steps where we can see that plastic impregnation can be there or oil impregnation can be there. So if we make a product out of a powder metallurgy, then that product, if we dip it in oil for some specified amount of time, this with the oil will impregnate into the pores of the powder metallurgy part, and this gives the self lubricating property to the bearing. So during the operation, when the temperature will rise or under certain pressure, under the application of capillary action, these oil droplets that are there in the powder metallurgy part will come out and they will give the lubrication property to the bearing. So that kind of things will come if we will subject the sintered part to these other optional finishing or the optional manufacturing steps. So, all these things we are going to cover in this series on powder metallurgy. Now, coming on to the introduction of powder metallurgy. The powder metallurgy existed in Egypt as early as 3000 BC. So, we can't say that it is a process which has been developed 2 decades or 4 decades back. The powder metallurgy dates back to 3000 BC. It was used in 19th century to produce platinum and tungsten wires. Already I have told you that tungsten wires are used as filaments in the incandescent bulbs. Then it was utilized in Germany for producing tungsten carbide cutting tool tips after the First World War. So, a wide variety of products are presently being made by the powder metallurgy process. So, we can just look at some of the products that are made by typical powder metallurgy process. So, we can see there are certain types of gears, there are certain types of sleeves, then there are other different types of products which can be made using powder metallurgy. Now, looking at these photographs, it seems that these are all metallic products. A simple question that can be asked is, can't these products be made by any of the normal manufacturing process or the basic manufacturing process that we have already seen? We have seen 5 different types of basic manufacturing process. What are those 5 different types of basic manufacturing process? Just to have a repeat, I will say the first one was casting, the second one was forming and shaping, the third one was machining, fourth was joining, fifth one was finishing. Now, a combination of these 5 processes can be used to make any of the products that is being shown in this picture. So, where does the powder metallurgy fit in? If we can make these products using any of those basic manufacturing process, why should we go for another process which we are talking? We are saying that powder metallurgy is an important manufacturing process. Why powder metallurgy is required? So, we will briefly go into the details of powder metallurgy. What are the application spectrums where powder metallurgy fit in? So, coming on to the, this is just to have a look at the tungsten light bulb filament. So, this has been shown at 300 microns and 40 microns. So, you can see that at a magnified image, this is the how the tungsten light bulb filament looks like. Now, why powder metallurgy is important? So, there are certain points that we would like to address as the importance of powder metallurgy as a manufacturing process. Now, first one is the melting point of the metal to be used for making a product is too high. Example is given tungsten. When we have to make a product of any metal which has a very high melting point. Now, suppose the first manufacturing process that we have considered, very basic manufacturing process, was casting. Now, what do we do in casting? In casting, we melt the metal in a furnace. Different types of furnaces are available like induction furnace, cupola furnace, electric arc furnace. Different types of furnaces are there. No, sorry, not electric arc furnace, electrical induction furnace. So, different types of furnaces are there which melt the metal, but none of the furnace can melt a metal which has a melting point as high as tungsten. So, there may be some specified some special furnaces which can be used for melting tungsten, but it is not usual or not off the shelf available furnaces. Now, as we can see that if the metal, the melting point of the metal is very high, then we can't use casting process because we don't have furnaces to melt those type of high melting point metals. So, we can make the powder of that metal and use it as a powder metallurgy raw material and use the process, the various steps of powder metallurgy to make any product out of that metal. So, the metals which have very high melting point can be utilized as a raw material for powder metallurgy applications. Similarly, the second point to be mentioned here is reaction occurs at melting. There are certain metals which react when they melt. The reaction may take place with the environment, it may take place with the atmosphere, or it may take place with the furnace in which it is being melted. So, when the reaction takes place on melting, the metal can't be used because some contaminants may add into the metal. Similarly, the third point is used for metals that are too hard to machine. Now, tungsten, if we want to machine tungsten, machining basically the basic principle is of relative hardness. If I want to machine something, I need a tool which should be harder than the workpiece. Now, tungsten is harder than most of the steels. Now, to machine tungsten, I need to have a diamond tool. Now diamond is very costly tool material and it can't be used as versatility as possible. So it is used for metals that are too hard to machine. Then it is used when very large quantity is expected. The production rate of powder metallurgy is quite high. So whenever we need to produce the metals or produce the final products at a very fast pace, we can go for powder metallurgy. So just to have a brief summary where powder metallurgy gains its importance, the first point is it is used for metals which have very high melting point, which can't be processed by basic manufacturing processes. Then it can be used for those metals which react on melting. The third point is it is used for metals that are too hard to machine, and then finally it is used where the production volume is very high. So these are the four basic important areas where powder metallurgy has found its application. There are other manufacturing processes also which have under special conditions can be used for these important conditions, but powder metallurgy is most suited where we encounter these four important conditions. If these four important conditions are encountered, straightforwardly we should choose powder metallurgy as the basic manufacturing process for these conditions. Now coming on to our next topic of discussion, that is how competitive powder metallurgy is. Already we have seen that powder metallurgy is an important manufacturing process. It has certain application areas where it has certain advantages as compared to the basic manufacturing process. So how competitive it is? Now competitive on the basis of the economics. Though powder metallurgy can be used for metals which have very high melting point, but sometimes the cost of the process also has to be taken into account. If the process is too costly, we can't use powder metallurgy as a manufacturing process for making final products. We have to upgrade our basic manufacturing processes so that we are able to produce the product at a relatively cheap price. So how competitive is powder metallurgy as compared to the other manufacturing process? Here we have certain points like what makes process attractive for producing a wide variety of products. The first point to discuss here is the availability of wide range of powder combinations. Here this property we can call it as the tailorability. Now whatever final properties we want, these final properties can be the mechanical properties, these can be the chemical properties. So depending upon the requirements of the final product, we can tailor our raw material. Like suppose we make a product of pure aluminum, it will have certain properties, certain specifications, and it can be used in certain application areas only. But if our application areas change, we need to change the raw material. So we can make a powder of aluminum, we can make a powder of some other metal which can be blended with aluminum in the mixing and blending stage, and then we can again make a product. Now this product may be superior to the earlier product which was made of pure aluminum. Now depending upon the final requirements may be depending upon the mechanical properties like tensile strength, shear strength, or it can be bulk modulus, Young's modulus. Different types of requirements may be there, mechanical requirements or different specific application requirements like self lubricating type of bearings, or there are sound deadeners. So different types of requirements are there. Depending upon the different types of requirements, we can tailor our raw material here. Tailor our raw material means we can blend different types of metal powders depending upon the requirements of the final product. So just to give you some examples, lead and copper for bearing surfaces, steel and copper can be blended to make a self brazing type of an alloy. So the first important point which gives a very good competitive advantage to powder metallurgy as a manufacturing process are availability of wide range of powder combinations. Then the second point is the ability to produce parts to net dimensions. So this is another important aspect of manufacturing, that is net shape forming. Already in the basic manufacturing process we have seen machining is one of the basic manufacturing process. What do we do in machining? We get a raw material, we remove some of the material in the form of chips, and then we get the final product. But here using the die and punch type of arrangement, whatever shape we want to make, we can make it directly. After that no machining is required. Although we have mentioned machining as one of the other optional manufacturing processes for powder metallurgy parts, but it is seldom required. Depending upon the shape of the die, depending upon the finish of the die, the internal surfaces, the finish of the internal surfaces of the die, we can make a product which is ready to use. Ready to use means it is a net shaped product, it does not require any subsequent processing. So, another competitive advantage of powder metallurgy is the products that we make out of powder metallurgy can be directly used, means do not require any further finishing, plating or coating requirements. So, if certain application specifies important characteristics like the plating should be there or coating should be there, only then it is required, otherwise after sintering directly we can use the product into the application area. Now, the last point is the economics of the overall operation. So, here I am not going to elaborate on the economics aspect of powder metallurgy, because we have a complete chapter or a lecture denoted towards the design and the economic aspects of overall operation of powder metallurgy. So, powder metallurgy till now we have seen that it is a competitive process, it has certain application spectrum where powder metallurgy has an advantage over other basic manufacturing processes, and it has a competitive advantage over basic manufacturing process in certain application spectrums. Now, coming on to the metal powders, all of us may think making a metal powder is very easy. Take any metal powder, use a hammer and try to strike it on the metal and we can make metal powder. It is not that easy. It is a very sophisticated, very important engineering process. So, metal powders are highly engineered materials. Metal powder, we can't make metal powders directly in our room or in our lab. It requires certain sophisticated processes, certain well controlled processes where there are different control parameters. Under those parameters we subject the metal or the molten metal, and then we make the metal powders. So, it is a highly engineered process or highly engineered spectrum of manufacturing process. So, metal powders are highly engineered materials. Now, coming on to what are these metal powders, what are the important aspects of these metal powders which affect the final properties of the powder metallurgy part. So, these are, the first is the particle size, the distribution and shape of the metal powder affect the properties of the compacted product. Now, if we see this sentence, there are three important points that have been mentioned in this simple sentence. The first one is the particle size, then the distribution of the particle size and the shape of the metal powder. So, all these three important points affect the final properties of the powder metallurgy part. The particle size, suppose we take an example, the particle size, if all the particles are of very big size, or we can say these are coarser in nature. So, if the particle size is coarse and they are uniform in size, the size is very big, there are bound to be certain pores within the metals. Now, simple example can be taken if we want to fill the tennis balls in a box. We take a box, put the tennis balls in that box. In between we will find there are too much of open spaces. So, these open spaces basically gives the porosity to the box. If we calculate the total volume will be the total volume of the balls divided by the total volume of the box. So, in this way, if the size of the particles will be very large, there are going to be a lot of porosity as well as the density will also be less. If the particle size is very small, then the density will be good and the porosity will be less. Now, depending upon that what type of properties do we want, we can choose the particle size. Similarly, the distribution of this particle size, as we are going to further go in our lecture, we will see there are different techniques for making the metal powders. So, the metal powders that we get out of these different techniques are of different sizes. So, there is a distribution of the size of the particle. Similarly, the shape of the metal powder. The shape of the metal powder can be needle like, it can be spherical, it can be any random shape. So, there are different manufacturing methods or different methods for producing the metal powders which can be used to make the metal powder. So, now these processes make the metal powder, and the shapes of the metal powder depend upon the method by which it has been made. So, three important points have been discussed: particle size, distribution and the shape of the metal powder. The shape of the metal powder also depends upon the manufacturing method used to make the metal powder. and all these three important aspects will define the properties of the final product, the properties like density, porosity, compressibility. Then coming on to the particle size. The particle size is usually measured by screening. Now, what is this screening process? Anybody who has certain idea regarding the casting, sand casting in particular, in sand casting we make use of sand. The sand has certain fineness, the sand grains are having a fineness. So, we calculate a grain fineness number. So, there are different sieves through which the sand is passed and we calculate the grain fineness number. Similarly, in case of metal powders also, the metal powders also have size. This size is the size of the particle. So, this is found out using a very simple technique, that is screening. Now, what is screening? In screening, we pass the metal powder through a set of sieves of various mesh sizes. Mesh sizes give the size of the pore or the size of the cavity inside the mesh. Now, the larger the mesh size, smaller is the opening in the sieve. So, using this kind of screening process, we pass the metal particles through a set of sieves, and then we see how much weight of the metal powder is left on one particular sieve, and on the basis of that we get an idea that what is the size of the particles in this metal powder. Similarly, we get the distribution of the particle size is given in terms of frequency distribution plot. The maximum is called the mode size. Now, it is not important to know that what is the size of the particle for a particular metal powder. As I have already told that there are different metal production methods. So, different metal production methods will make the metal powders depending upon their properties. Now, some of the metal powders will have very big sizes, some of the metal powders will have very small sizes. Similarly, the size will be varying for one particular type of a metal powder. Now, sometimes suppose we take a case of 100%. Now, out of 100%, 10% of the particles may be of one particular size, 20% of particles may be of other particular size, and 50% of particles may be of different particular size, and the remaining can be of the different particular size. So, the particle size is varying over the total metal powder, total quantity of the metal powder. So, on the basis of what is maximum, we say this is the mode size of this metal powder, 50% of the particles are of this size. This I will explain with the help of some diagrams also. Now, till now we have seen two important aspects of metal powders. First one is the particle size, the second one is the distribution of the particle size. Now, coming on to the third important aspect, that is the particle shape. Now, particle shape is described in terms of the aspect ratio. Now, aspect ratio is the ratio of the largest dimension to the smallest dimension of the particle. The largest dimension to the smallest dimension. If we take a case of a rectangle, now a rectangle has a larger dimension that we call as length, and a smaller dimension that we call as breadth. So, length and breadth, ratio of length and breadth will give the aspect ratio for the rectangle. Similarly, as mentioned here, the aspect ratio ranges from unity for a spherical particle to about 10 for a flake like or needle like particle. If you take example of a sphere, sphere has only one particular geometrical entity, that is we can say it can be specified with the help of a radius. Now, radius is constant. If we take r by r, maximum and minimum ratio, it gives us r by r, because r is equal to r, it gives us a value of unity. Whereas, in a needle like or a flake like particle, it will have certain length, or if it has a round cross section, it will have certain radius or certain diameter. Now, ratio of the length to the diameter will give us the aspect ratio. So, these aspect ratios for needle like or flake like particles may be 10 or even more, or it can be less. So, now we have three important aspects for metal powders. The first one being the particle size, the distribution of the particle size that we call as the frequency distribution, and finally the third important point, that is the shape of the metal particle. So, all these three important points will affect the final properties of the powdered metal product that we are going to make using the basic process of powder metallurgy. Now, here we can see two photographs have been shown. The upper one being the scanning electron microscopy photograph of iron powder particles made by atomization. Now, atomization may be a new term to all the students. Now, atomization, we will see what is this process of atomization in the course of this lecture only. And the second photograph shows the nickel based superalloy powder particles made by rotating electrode process. Now, rotating electrode process is also a new term, but the powder particles is what we have been discussing till now. So, here we can see in the second photographs, these are the particles. The particle is of a very big size. There are other particles which are of relatively smaller sizes. So, we can see that the particle size is important. Moreover, the distribution of the particle size is important. Now, if we count the number of particles having a very large size, this is very less. If we calculate the number of particles with this size, we can see that there are number of particles having relatively this size. So, we can say the distribution of this size in the metal powder is more as compared to this bigger size. Similarly, the shape of the metal powder particles, here we can see the shape is random shape. So, if we want to calculate the aspect ratio, we will see what is the largest dimension. Suppose now this is the largest dimension and this is the smallest dimension. So, we can calculate the L by D ratio for this and we will get certain value for that. So, we can get the shape of the particle, we can get the size of the particle and we can get the distribution of the size. Now, sometimes this size may be in larger number, sometimes this size may be in larger number. So, metal powders that we make, those are having three important characteristics. First one is the particle size, the second one is the distribution of the particle size and the third one is the aspect ratio, or we can say the shape of the metal particles. Now, this may not be too much clear, but just to name a few metal powders. The metal powders can be made up of pure metals, it can be made up of alloys, or it can be made up of compounds. So, we can get powdered metals of aluminum, antimony, bismuth, cobalt, lead, tantalum, titanium, vanadium. Then we can make metal powders of certain alloys also, like aluminum iron alloy we can make metal powder, brass, nickel copper, nickel iron, solder, stainless steel, all these alloys can be made into a metal powdered form. Similarly, there are certain compounds of which we can make metal powders. These are borides, these can be carbides like tungsten carbide, molybdenum disilicide can be used, nitrides can be used. So, there are different types of categories which can be used to make metal powder. So, these can be pure metals, means the powders of pure metal, the powders can be of alloys, or the powders can be of compounds. Coming on to the characteristics of metal powder, till now we have seen the geometrical features of the metal powders like the particle size, the distribution of the particle size and then the shape of the particle size. Now, it has certain characteristics. Now, the important characteristics we will just briefly go through these important characteristics of metal powders. The first one being the apparent density. The apparent density or specific gravity of the powder is expressed in kilogram per meter cube. It should be kept constant. This means that the same amount of powder should be fed into the die each time. Now, this is important, the same amount of the metal powder should be fed into the die each time. Why? Because if we feed more metal or less metal, we may not be able to get the exact shape of the final product that we want to make. The second important characteristic is chemical properties. These are the properties like the purity of the powder. Already I have told that metal powders can be made up of pure metals, the amount of the oxides permitted and the percentage of other elements allowed. Now, the amount of oxide permitted and the percentage of other elements allowed is important, because if we have too much of oxides in the metal powder, or there are other elements in the metal powder, the when we compact this metal powder is always in contact with the die surface. Now, if these particles are abrasive in nature, or these we can say that these particles which are the other elements or the other oxides which are not required, these may abrade the die surface. So, we have certain points dedicated to the die materials also, which will be seen in subsequent lectures. So, the wear of the die is very important. So, these important things like the oxides or the percentage of the other elements may affect the surface of the die or may cause the wear of the die. So, there is a limitation on the percentage of oxides allowed as well as the percentage of other elements allowed. The third important characteristics is the compressibility. Now, what is compressibility? Compressibility is the ratio of the volume of initial powder to the volume of the compressed piece. It varies considerably and is affected by the particle size distribution and shape. Compressibility affects the grain strength of a compact. Now, if the metal powder do not have these characteristics, we will not be able to make a compact or a grain compact out of a metal powder. If it is compressible, we can compress it and apply certain pressure in the step that is called compaction, and we can get a grain compact. If it is not compressible, we will not be able to get a grain compact. Even if we get a grain compact, it will not have adequate strength to sustain the other operations that are subsequent to the step of compaction. After compaction also, we have to take into account different steps, like we have to use that grain compact for sintering. After sintering, we have to use it for other optional manufacturing process. So, the other important characteristics is fineness. Now, fineness refers to the particle size and is determined by passing the powder through a standard sieve or by microscopic measurement. Already I have told that we can calculate the particle size using the screening process, which is mentioned here as passing the metal powder through a sieve. So, fineness is also an important characteristics of metal powder. Then other important characteristics is flowability. The metal powder should be having this property of flowability. What is flowability? Now, flowability is the characteristic of a powder that permits it to flow readily and conform to the mold cavity, as we will see in the subsequent lectures that we make the mold cavity of the shape of which we want to make the final product. Suppose we want to make the final product in the form of this mouse. So, we will make a mold cavity, or we can call it a die cavity of this shape, and fill the metal powder in this. So, if the metal powder has the flowability characteristics, it will enter into the mold cavity and will reach to the farthest corner of the die cavity or the mold cavity. If it is not flowable, it will not reach to all the corners of the die cavity, and the final product that we get will be a defective product. So, the flowability is an important characteristic of metal powders, and metal powders should have adequate flowability. It can be described as the rate of flow through a fixed orifice. So, we can pass the metal powder through a fixed orifice and get an idea about the flowability characteristics of the metal powder. Another important point is the particle size distribution, which has already been discussed in the geometrical features of the metal powders. So, the particle size distribution refers to the amount of each standard particle size in the powder. It influences the flowability and apparent density as well as the porosity of the product. Example already I have given, filling up of the tennis balls of same size inside the box. So, there will be certain porosity will be there. If the size is less or more, the porosity will be affected accordingly. Coming on to the next metal powder characteristics, it is the sinter ability or the sintering ability. Sintering ability is the suitability of the powder for bonding of particles by the application of heat. Now, in sintering process, the different individual metal powder particles are subjected to temperature and they form a bond with the adjacent particles. So, if the metal powder have this property of sinterability, they will have form a bond and they will improve the density of the metal powder. If they do not have this type of a characteristics, so the bonding between the two adjacent metal powder particles will not take place, and finally, the density and the porosity will be affected accordingly. So, the metal powder should have this characteristics of sintering ability. Now, we have discussed till now some of the important characteristics of the metal powder. Now, we will see how these metal powders can be made, how these metal powders can be manufactured. So, there are certain processes, to name them: atomization, reduction, electrolytic deposition, carbonyls, comminution and mechanical alloying. So, with the help of diagrams or with the help of certain explanation, we will try to go through each one of these powder production techniques. So, coming on to the first one, that is the atomization. So, the two diagrams are given here. Already when we saw two diagrams or the scanning electron microscopes for two different metal powder particles, we have seen that one of the SCM was for atomization, the other one was for using the standard electrode method or the rotating electrode method. So, here we can see in the atomization process, just to read out what has been labeled in the diagram. There is a molten metal, there is a ladle, there is a atomizing water spray, there is a atomizing chamber, and there are the metal particles, or the metal particles or the final particles that have been produced by the process of atomization. So, the basic process here is the molten metal is forced through a nozzle into a stream of air or water. Upon contact with the stream, the molten metal is solidified into the particles of wide range of sizes. As we can see, the particles of wide range of sizes. So, first coming on to the process, the molten metal is taken, it is passed through a tundish, through a nozzle into a atomizing chamber. In the atomizing chamber, there is a atomizing water spray. It is not important that the water spray should always be of water. It can be of air also, it can be of any other inert gas. So, under the application of this atomizing spray, the metal particles that are coming out of the nozzle will form the different shapes. So, we can see already it has been told that the molten metal is solidified into particles of wide range of sizes. So, the size that we will get out of this process of atomization will not be same, the particles will be of a varied size. So, this is the first process to convert a molten metal into the metal particle, passing it through a nozzle. Coming on to the second process, that is the using a rotating consumable electrode. So, basically this is a application of a welding process only. Here we can see that, just to see how the diagram has been labeled, there is a inert gas, there is a vacuum that has been created in the chamber, there is a rotating consumable electrode, there is a non-rotating tungsten electrode, there is a collection port where the metal particles will be collected, and there is a spindle to give a rotatory motion to the rotating consumable electrode. Now, in this process, when there is two electrodes, the rotating consumable electrode as well as the non-consumable electrode are brought together, a current passes through these two electrodes and a arc is set up between the two electrodes. Now, one electrode, that is the rotating electrode, which is the consumable electrode, is rotating at a very high speed. Now, under the centrifugal forces, the metal which is melted at the tip of this consumable electrode forms into a type of a droplet, and this droplet of metal powder falls into the collection port. So, this particular process makes use of the basic principle of welding, where we are bringing together two electrodes together, and one electrode is a consumable electrode, another one is a non-consumable electrode. So, this consumable electrode is the electrode made up of a material of which we want to make a metal powder. So, this will be consumed in the process and we will get a metal powder by using this process. So, this is the first process for making a metal powder. Now, the second process is the process of reduction. So, what is this reduction? Reduction is, as any student of chemistry knows, that the process of reduction, the reduction of metal oxide, removal of oxygen, uses gases such as hydrogen and carbon monoxide as reducing agents. Very fine metallic oxides are reduced to metallic state. The metals produced by this method are spongy and porous and have uniformly sized spherical or angular shapes. So, important points here are: the metals produced by this method are spongy and porous, as well as they have uniformly sized spherical or angular shapes. Now, the shape has been given here, spherical or angular. Now, this shape of the metal powder that has been made by this process of reduction influences the final properties of the final product. So, if they are uniformly sized spherical particles, the porosity will be more, the density may be less. Now, depending upon the size of the particles, we can see also depending upon the size as well as the shape of the particles, we can see whether these particles will form a dense product or these will form a porous product. Depending upon the size, these properties will be defined. Now, reduction is another process where the metal oxide are reduced using reducing agents such as hydrogen and carbon monoxide. Now, the third process for making metal powder particles is carbonyls. Metal carbonyls such as iron carbonyl and nickel carbonyl are formed by letting iron or nickel react with carbon monoxide. The reaction products are then decomposed to iron and nickel. They turn into small, dense, uniform, spherical particles of high purity. Again, here we can see the emphasis is on the shape and size of the particles. We can see using this process of metal carbonyls where iron and nickel carbonyl are formed, where iron and nickel react with carbon monoxide and the reaction products are then decomposed to iron and nickel. The final emphasis is on the process is there, but the final emphasis on what are the type of, what is the shape of the metal powder that we are getting, what is the size of the metal powder that we are getting. The size is small and it is dense, it is uniform. Uniform means, as in atomization we have seen, the particle size is varying. Sometimes we may get bigger particles, sometimes we may get smaller particles, but here using this process of carbonyls we are going to get small particles, we are going to get dense particles. The size of the particles will be pretty much uniform, the shape will be spherical, and these will be particles of high purity. So now we come to the end of first session on powder metallurgy. I will just try to summarize what we have covered in this first session on powder metallurgy. We have covered the introduction to basic manufacturing processes. 5 basic manufacturing processes have been addressed, that is casting, forming and shaping, machining, joining and finishing. Then we went on to the introduction to powder metallurgy, what are the various steps, basic steps of powder metallurgy. After that we went on to cover the basic characteristics of the metal powders, what are the important properties of the metal powders, and then we went on to discuss some of the important metal production techniques, out of which we have covered atomization, reduction and carbonyls. Now in our next lecture on powder metallurgy we will start our discussion with metal production techniques, in which we will cover mechanical comminution, or which we can call it as pulverization, and after that subsequently discuss the various steps that are used to make a product out of powder metallurgy. Thank you.
Thank you.